Let's see. I have the wrong camera looking at me here. Switch it over here. Dallas, where are you? Expected to see you here in cohort A today. Got mixed up? Yeah. If you want, so tomorrow, so it'd be tomorrow. If you want to come on in, you come in for, yeah, your period's 246 tomorrow if you want. Let's see here. We got everybody in the waiting room. Now I just need to mark everybody who's actually here right now. So we've got Aiden is here. Let's see. Adriana is here. Yes. Figuring out how I'm going to do attendance for the two groups. Adriana, and then Liliana was here. Multitasking at its finest. Okay. Okay, did Maya come in? Is Maya here? No? But Bella? Are you Bella? Okay, perfect. And Preston is here. Dallas. Charlie's here. George is here. Carlos is here. This is here. Alexis. Morning, Alexis. Nice to see you in person. How's cheer going? Yeah. How often do you have practice? 2 days. Is it the day? Is it going to be like the days that you're here on campus, or? No, it's just Monday and Thursday. Monday, Thursday. Okay, cool. Go. Awesome. So I think I've got everybody there. So it's like first day of school. Faces. This is like awkward almost. I've been like this in my living room for so long. So good to see you guys. Glad you're here. Super excited for school to be back in session here with you guys. How you doing, Preston? Good. Yeah. Glad that you're here. You got something? Got you excited about tomorrow? You have any plans for tomorrow? No? No? Okay. I think. Your birthday tomorrow? Happy birthday. All right. Well, let me go ahead and sort of jump into some stuff here. Let's see here, make sure that everybody can see me. So over here. There we go. All right. So good morning, everyone in Zoom land. Can you guys see and hear me okay? Let me know in the chat. At home, can you guys hear me okay? Cool. Hi, Evelyn, Anthony. Anna. Cool. Wow. Fantastic. Getting some great feedback there as well. So awesome. So we've got some of your classmates here in class with us today. And then we got all of you who are participating from home. Some of you are going to come in on Thursday, Friday. And in that case, we'll have I'll see some more faces, some more of you on Thursday when you guys come in for 135 on Thursday. So looking forward to that. For those of you who are here, I do have a schedule up here for you guys. So the schedule is different now. It's a modified bell schedule now that we're in hybrid. So we go straight through with all of our classes, and then there's a grab and go lunch at the end of the day. So in case you missed that memo, so this class first period, the day goes till 10 o'clock, and then the second block goes from 10:10 to 11:40. And then the last block will go from 11:50 to 1:20, and then there's a grab and go lunch at the end of the day. So I know it's a little bit of a long stretch, but we can do it. I'm on the same long stretch as you guys, so we'll get through. Anything else that I need to go over in terms of announcements? I don't think so. Okay, so today we're going to go over some stuff on the Pythagorean theorem. Oh, I guess. Okay, so so in terms of things that you brought with you guys bring any notebooks? Probably notebooks would be good, and a Chromebook. We'll get to the Chromebook stuff in a minute, but you guys have notebooks? Right on. We're just going to take that out. That way you can write down some examples and stuff like that, and then you can use those to help you when you get to like the homework part. So take out like a notebook, something to write with, and I'll do some examples, some notes with you guys. It probably feels weird to be sitting at a desk with a notebook instead of lying in bed with a computer. And getting dressed instead of wearing pajamas, things like that. We'll work our way through. Rating? Some out? Oh, you don't have any? Oh. No, but for now, you can just check out the notes. I'll post them up. Then if you don't have anything, just next time try to bring some notebook or some paper. All right, so we're going to talk about the Pythagorean theorem, which should be pretty familiar with you guys. What do you know about the Pythagorean theorem? Anything? Or in the chat, you guys can chime in as well. What do we know about the Pythagorean theorem? Anything in mind? Doesn't have to be all of it. Has to do with right triangles. Specifically, how the sides of that triangle are related to each other. We usually call those three sides A, B, and C. Anybody know our famous equation that goes with this? Charlie?
Yes.
Know the equation that goes with this? With A, B, and C, Pythagorean theorem? Yeah. Starts out with A squared. Anybody else want to jump in? Hold on. This is one you guys probably learned in middle school. Carlos? No? Beta? No? Okay, so does this look familiar at all? A squared plus B squared equals C squared? And so this is what we call the Pythagorean theorem. Yes, George? No? Okay, cool. So A squared plus B squared equals C squared. So this is the Pythagorean theorem. And basically what this says is that in a right triangle, which is what this is, I'll write it like this. Leg squared plus leg squared. I want to write that down lower. Leg squared plus leg squared equals hypotenuse squared. So the legs are these sides of the triangle. It's like this side is one of the legs of the triangle. This side, B, is the other leg. And then the third side, C, is what we call the hypotenuse. That's the longest side of the triangle. And you can always find it by looking where the right angle is. It's always the one that's directly across from the 90-degree angle. That side of the triangle has a special name. We call it the hypotenuse. Okay? So we're going to be using this equation. We're going to be using this equation to find unknown sides of right triangles. So we'll have a triangle. I'll tell you two of the sides, and then you can use this equation to find the third side of that triangle. Okay, so for example, let's go and get this up over here. Keyboard here. Let's take a look. This one have a diagram. Perfect. I like this. This is good. Okay. So let's go ahead and try this one. I want to find the length of the third side. paste. There. So we want to find the length of the third side, and if necessary, we're going to round that number. Do some rounding to the nearest 10 if we need to. You guys see that okay? Now I have to make sure that you can see it on the screen and in the classroom, so it's kind of fun. New challenges. All right, so we want to find the length of the third side, and if necessary, round to the nearest 10. So what we're going to do here, first of all, we have a right triangle, and you'll notice that, just like I said, I told you I'm going to tell you 2 of the sides. We know how long this side is. We know how long this side is. What we want to find is the length of the third side. We can use the Pythagorean theorem to do that. I'm going to call this third side, I'm going to call it x, so we don't know how long it is. And then we're going to write our equation of Pythagorean theorem, which is a squared plus b squared equals c squared. And then we want to plug in each side for A, B, and C. We're going to substitute, we're going to replace those with the values on the triangle. Now, it kind of matters where they go. So we have to kind of figure out where each of these things are going to go. The one that's really important, A and B can be switched. So A and B, it doesn't matter which one is A, which one is B. Those are both of those are the legs. It doesn't matter which leg is which. The one that really matters is the hypotenuse. So, does anybody have a guess as to which one of these is the hypotenuse? Which one is C? Give me a sec. Yeah.
20.
Why do you think that?
Because it's the longest.
Yeah, kind of looks like the longest side. This does not look the longest. This is the longest side. Very good. And you can always tell that if you look at the 90-degree angle here, it's always pointing directly across at the longest side as well. So very good. 20 is the longest side. So we need to put the 20 over here. It's going to be 20 squared. Now the other 2 don't matter. Okay, they're both legs. The other 2 sides are both legs. So I'll just put x squared plus 12 squared. We do need to square both of them still. Okay, so we've got x squared, 12 squared, the other leg, and then 20 is the hypotenuse. That's the longest side there. Okay, so that's going to be our basic equation now. It's an algebra problem. We're going to go through and solve that equation. Go ahead and try that. You can just kind of work through that. You want to simplify. Start by simplifying the blue and the green. Right, 12 squared and 20 squared. Do you guys have calculators? You can use your phones if you want. I'm going to not be real picky with the phone thing right now. So what? Let's see if you can solve that. Okay, maybe some people in Zoom want to chime in. Don't want to forget about all of you here. So out there in Zoom at home, what's our new equation if we simplify this? X squared plus what? You guys still paying attention out there? What's 12 squared? Thank you. Got some good things. All right, perfect. Thank you, Anthony. 144 equals 400. So this is going to give us 144 equals 400. Perfect. You guys get that? So we got 12 squared is 144, 20 squared is 400. And then what do we do next? Perfect. Another color. So we're going to subtract 144 from both sides. Which will give us x squared is equal to what? You're always welcome to chime in on Zoom as well. Watching both. Or you can turn on your microphone too. It's more voices. 400 minus 144 is
256.
Charlie? 256. So we're gonna get that. And then how do we get rid of this square? This x squared equals 256. We want to know, what does x equal? Talked about this a while ago. We were dealing with quadratic equations. How do we get rid of the square? This thing? What's that called?
Division. Oh. Anyways.
What is it? Yeah, square roots. Very good. So the opposite of a square is a square root. And this is what we use to get rid of squares. So we would do the square root of x squared and the square root of 256, right? We do the square root on both sides. Easier to see. All right, so we're going to take the square root of both sides. And the square root of x squared is just x. That's how we get rid of the exponent. Square root of x squared is just x, and then on your calculator we can just punch in square root of 256. Now, if you're using your phones, the way you do that is you type in 256 first, and you press the square root key. If you're using like the Desmos Scientific Calculator app that I highly recommend, it's so cool, very good calculator, you would do the square root button first and then type 256. Either way, I believe it comes out to a whole number. Got it there, Carlos? 16, thank you. So we got x is equal to 16, perfect. All right, and that is the length of the missing side here. This side of the triangle would be 16, and that kind of makes sense. You know, the longest side is 20, so this side has to be less than that. It's got to be shorter than 20, and it is. So it's like this side would be 12 inches, this side would be 16 inches, and the longest side would be 20 inches. So our answer here, though, is 16. That would be the length of the longer of that side, the trunk. 12, 16, and 20. And that's how we use the Pythagorean theorem to find those missing sides. That makes sense? Any questions on that one? Glasses fog up. Problems that people with glasses have with masks. All right. Now, it won't always come out to a whole number. Notice that up here it says, if necessary, round to the nearest tenth. So sometimes it doesn't come out to a whole number, in which case we'll have to do a little bit of rounding. Try to see if we can find an example like that. Let's see. Any questions on Zoom, by the way, on that one, guys? So 16. Oh, let's do anything interesting here? Not really. It's like they did all the same stuff we did. Okay, all good in Zoom. Let's see here. Is this going to be a whole number? I think it is. Or looking for one that's not a whole number. Yeah, it's a whole number. Okay, this looks good, I think. Let's try this one. I'm gonna give that one a try. You have an example to go off of already. See if you can set up the equation. We'll put an X here since that's the side that we're trying to find. See if you can set up your equation and see what you can get there. Ever complicated? You want to start working on like just try some of the ultimate problems. That's what we're going to work on next. Check that out. Try just do another example or two. You can do that too. So I remind myself to develop. Moving on. It's Audrey. What was your name? Alexis. Yes, I was right. Second guessed myself. Okay. So what's our equation here? Yeah, Eliana, didn't get anything here yet? What's your George? Yeah, where'd you put these things here? $20 squared plus x squared equals 24 squared. What do you guys think? Is that what you bet? 20 squared plus x squared equals 24 squared. Yes, no, what do you guys think? Yeah, okay. Yeah, and you may have switched the 20 and the x, and that's okay. As long as you have the 24 over here, good to go. So perfect, looks good. All right, so now that we've got that taken care of, I mean, again, the important part here is that you get the hypotenuse is 24. As long as you've got hypotenuse is 24, the longest side, the other two sides don't matter as much. Okay. Anybody simplify this already? The 20 squared and the 24 squared? 20 squared we did last time. That's 400, right? What's 24 squared?
476.
576. Perfect. 576. 400 plus x squared equals 576. And then? Perfect. Subtract 400. X squared is equal to
176.
176. And what do we do to this? Square root, yes. So we're going to take the square root of both sides. And this, I'm fairly certain, does not come out to a whole number.
13.2.
Can you go one past that? Because I want to make sure we can talk about the rounding, how the rounding works.
13.26.
So x is equal to 13.26. So when they say round to the nearest tenth, it doesn't mean just stop at the tenths. It actually means go one past that, 13.26, right? You got to go one past that, and then you're going to look at this number. That number is going to tell you if we're going to round up or keep it where it is. So it's a 6. What do we do with a 6? Does that round up or stay? Okay, we're going to round that up. So it's actually not 13.2. We're not going to stay there. What is our actual answer? 3. Right? Because it's actually closer. It's actually closer to 13.3 than it is to 13.2 because of that 6 after the 2. So our actual answer here, rounded to the nearest tenth, would be 13.3. And that's this side right here, 13. And again, that should make sense. You know, you can look at the picture, make sure that the picture makes sense to you. You know, this side here looks shorter than the other sides. And it is, you know, 13.3 is less than 20 and it's less than 24. That kind of makes sense in terms of the picture. That's good. Any questions on that one? We got to do a little bit of rounding, so that's good. Questions are always okay. Oh, plenty of time. I just wanted to show you, I think, one where there's no picture. So there's a few problems on the Delta Math where there are no pictures. Like this one here. One of the legs of a right triangle measures 14 centimeters, and the other leg measures 5 centimeters. Find the measure of the hypotenuse, and if necessary, round to the nearest 10. You may remember when I wrote the notes on the first screen, I wrote that a squared plus b squared equals c squared, but I also wrote it words. Leg squared plus leg squared equals hypotenuse squared. And that's what we're doing here. A and B both represent legs. So they say one of the legs of a right triangle measures 14 centimeters. That's one of them. It says, and the other leg measures 5 centimeters. And we want to find the measure of the hypotenuse. This is where we're going to do that leg squared plus leg squared is equal to the hypotenuse squared. And if you want, you can draw a picture of this. Not necessary, but always, it's never a bad idea. You can draw a right triangle like this. And they tell us that one of the legs is 14 and one of the legs is 5. So I could put like a 14 on one of the legs. I could put 5 on the other leg. I could put an X on the hypotenuse because they want us to find it. It's like do something like that. So if you're more visual, you like to see a picture, you might try doing something like this. If you don't need the picture, you could always just go straight to your equation and you're like, okay, I know I need to do leg squared plus leg squared equals hypotenuse squared. Whatever you're more comfortable with, whatever helps you more. All right, so what is our equation this time going to be? Go ahead and try writing an equation right now. See what equation would you write down for this?
14 squared plus 5 squared equals x to the second.
Very good. We've got 14 squared plus 5 squared equals x to the second, or x squared. And we're going to solve that equation, and then we'll pretty much be done. done at that point. So this will kind of be our last example. I'll give you some time to get your delta math done and over with, so you don't have to have homework, which would be awesome. Maybe some interaction from Zoom. You guys have been getting off. Go ahead and try simplifying this equation here. 14 squared plus 5 squared equals x squared. What's our equation after we simplify that? $196 plus 25. Thanks, Anthony. So we got 196. What is that? I don't even know. 196 plus 25 is equal to x squared. Okay, what do we do now? Previous problems we have to subtract, but not this one. What do we do now?
Add it together.
Yeah. Yeah, we can just combine these numbers together. So we're just going to combine 196 plus 25. Give us 221. Yeah, 220. This next part I cannot do in my head though. So I need you guys to help me out. What is the square root of 221? Square root of x squared is square root of 221. Get that, Alexis? 14.9. Can you go one past that?
That's the rounded number.
It is rounded?
Yeah.
Can you still go one past that, just so I can?
It's 14.86.
14.86, perfect. I just want to, just for the benefit of everyone else, 14.86. I just want to show the rounding part. And then yes, you are correct. That's going to round to 14.9. Very good. All right, so because of that 6 there, we're going to round that up to 14.9. That would be the measure of the hypotenuse. So that's pretty much the basics of the Pythagorean theorem. We're going to obviously go do a little bit more with this later in the week, but this is just kind of get things started. Also kind of easing into things because this is like first day back on campus for you guys. It's like, you know, experiencing shock. It's like, oh my goodness, back in the classroom. All right, so I'll give you guys some time right now to work on some of the delta math, and you can ask questions if you have questions. I can do more examples either on the screen or the whiteboard. I'll probably do the screen. That way you people at home are not left out. Hello. This is my portal to everyone at home right here. It's camera. Okay. 14.86. Okay, cool. So that's gonna work on some delta math. Any questions? White noise. It's so quiet. By the way, did everybody in here take the test on Thursday? We didn't have, because there's no Zoom meeting. I was like, how'd you guys go on and take a test? You guys take that test? Yeah. If you missed that, I make that up on Wednesday this week. Or sooner. I mean, you guys need to make stuff up. We can probably work on that here in class. And for those of you who are at home, joining us from home, yeah, if you still need to make up that test, if you missed the test on Thursday last week, we will probably have like makeups as well as test corrections. So I'll have corrections available for you guys on Wednesday this week. So I'll give you a chance to either make it up or do corrections on Wednesday. So Oh yeah, simplifying radicals. You know, I didn't do any examples of simplifying radicals. You guys have any questions on that? We did that a while ago. You guys remember how to do that? I need to do an example of one of those. Would that help? Yeah. Um, um, it's I didn't do any examples of that first topic. The simplifying radicals. That's an older topic, kind of a review. It's like how to simplify radicals. And we're gonna get into this, we're gonna use this more later this week. So it's a very simple example. Does anybody remember our strategy for this? What we do? Simplify this. The square root of 12 is not a whole number. If you want a decimal, you just punch it in your calculator. But what happens if you want this in what we call, what if we want simplest radical form? So we call an exact. Remember what we would do with this? These two square roots. Break it up into two square roots. And we would do that by factoring 12. We'd look at what numbers multiply to 12. We're going to break that up into two square roots. How would we break up 12? What numbers multiply to 12? Got 6 and 2. So we could do the square root of 6 times the square root of 2. That's a possibility. What other numbers multiply to 12? Three. Now, so technically, both of these equal the square root of 12. Here's the catch. Is the square root of 6 a whole number? What's the square root of 6? Can you think of, like if I ask you, what's the square root of 6?
Where's the decimal?
Yeah, it would be a decimal, but not a whole number, right? We want to break this up in a way where we're going to get some whole numbers. Square root of 2, is the square root of 2 a whole number? No, that's also not a whole number. What about the square root of 4? Yeah, this is a whole number. And so we don't want to use 6 times 2 because neither of these are whole numbers. The square root of 6 is not a whole number. The square root of 2 is not a whole number. Okay, so we don't want to use this one because we don't get any whole numbers. But over here, we can simplify this, right? But what's the square root of 4? Yeah, this equals 2. And the square root of 3 is not a whole number, so we're going to leave that one alone. We're not going to change that. We just simplify. All we do is we simplify the square root of 4. Okay, this is what we simplify. The square root of 4 is equal to 2. Square root of 3, we leave it alone. And so our answer is 2 square root of 3. And that's how you simplify. That's how you get simplest radical. So you have to break it up into 2 square roots, but not just any 2, right? You want to break it up so that you can simplify one of those square roots to a whole number. Like the square root of 4 is equal to 2. Here I would put in 2 and press the square root button and 3. 2 square root of 3. They go through it a slightly different steps right at the beginning, but you see that they get to the same place. They break up the 12 into 4 times 3. And then the square root of 4 is 2. Does that help? Anybody have an example that they're working on right now on this? What do you got, Preston? You're working on this, right? Yeah. What number do you have right now? Square root of what? 54? Square root of 54. So we know we want to break this up. That's a really weird square root. There we go. We know we want to break this up. Bigger number though, so we might have to think about it. It would be, we know we want to get a whole number, right? It might be helpful if we knew what numbers will give you a whole number when you take the square root. What numbers have whole number square roots? Do you guys like a list of those numbers? It's actually pretty easy to make. The list is the list of what's called perfect squares. So the numbers that you're looking for are the numbers 1, but 1 doesn't really help us. 4, 9, 16, 25, 36, 49, 64, 81, 100. Keep going off the screen. 1, 100. 11 squared is 121. 12 squared is 144. So those are all the perfect squares. This is a 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 5 squared, 8 squared, 9 squared, 10 squared. Those are the numbers that you want to use when you break this up. So do any of those numbers go into 54? All right, I should say one of them does. I should ask you which one. Which one of those numbers goes into 54? Maybe a good question. It's your problem here. One of these numbers goes into 54. Yeah. 9 times what? Very good. So 54 would break into 9 times 6. And then we can simplify this part of it. What's the square root of 9? And then the other part is the square root of 6. We leave that part alone. We only simplify the one with the whole number. Square root of 9 is 3. And this would be your answer. 3 square root of 6. Okay? So that's how those ones work. And if you have a bigger, like 12 is easy, it's small. Right? If you have a bigger number, I recommend look at the list and ask yourself, which one of these numbers goes into my number? And then break it up that way. Here, take care of the delta move, Carlos. Got it all? I guess if you guys are finished early with stuff, I mean, obviously you can work on your math homework, you know, get caught up with some of that. If you have any missing assignments, you're welcome to do some of that work. And then if you have any missing work if you have any work for other classes, you're welcome to do that in here as well. So, you're caught up with everything. You chat, hang out, get some of that social interaction that you haven't had at school for a long time. back. Mhm. Yes. Absolutely here. Then,
Yeah.
that works too. You can do that or you can fun. Caught up with your other classes, Carlos? Yeah. Pretty easy stuff. Sorry. What's your hardest class right now? Good. Chemistry usually is the hardest class for. That's one of the top picks for first class. That's great. No, so I got the answer up there on the screen. Remember, so we had to break it up into 9 times 6. And the square root of 9 is 3. So your answer should be 3 square root of 6. So square root of 198. A little bit bigger. Same thing though. So you can figure out which one of those numbers goes into 198. The bigger the better. It's actually, I think, technically 2 of those numbers go into 198. answer's not in the poll. Well, I think 16 goes in. 16 go into 100. Scroll down. Oh, 36. See how 36 times 3. Square root of 36. Six. That's this choice quantity. Two numbers. Two square roots. What's going on here, guys? Any questions? All right, it's good. I should put you guys in like breakout rooms while you're here for like the next few minutes. So we're on our new schedule. As we go, we'll get out at 10. That's in 9 minutes from now. So is the class full? Not really. Is class full? No. All right, 9. Got 9 people here right now. I think my largest group from any class is 13 at a time. It's the largest group I have. My smallest is like 4.
That's all extremely awkward.
Yeah, right? You're like, yep, just the teacher and 4 of us. Best buds. Yeah, it'll be interesting. We'll see how that class goes. All right. Let's see here. Now, at the end of class, they were sent because they did. Originally, what they told us is you guys should wipe down your desks at the beginning of class and again at the end of class. Not sure why, because the next class is going to come in and wipe down the desks again. But I'm trying to decide if we should just go with that, wipe them down at the beginning and the end, or just the beginning. Personally, I like the idea of just doing it at the beginning because then you're just, you know that you cleaned your desk. You're not depending on, did somebody else clean the desk? It's just, you know, I wiped this desk down. But seems wasteful to do it at the beginning and the end. Just only have 1,200 wipes in that bucket, so. Only. Fun math problem though. How long would that last? I kind of figured if I have an average of, say, 30 students a day actually coming in here.
How many are there?
1,200 wipes. I have an average of 30 students a day, 4 days a week, because no one comes in on Wednesdays. So if there's 30 students a day, four days per week,
using them once or twice a week,
Well, and that's the
or
question.
like once or
is-
twice a day.
Yeah, see, if each student's using 2 wipes at beginning and end, that's 60 wipes. So yeah, let's see how long would it last if we're using it
You wouldn't
twice.
have enough, because if you did it just 30 students, one a day, it's already coming down to 10. So you'd be short if everyone used it. It'd only last 10 days. And
10
that's if
days.
everyone only used one.
10 days, really?
Yeah.
That was a lot longer than that. Wow, yeah. Well, because 1 a day,
But you have to multiply 30 by 4,
which is
120. I think.
yeah, 120.
And if everyone used it twice a day, you'd have to double that number.
Oh, but that's weeks though, I think, right? Because yeah, that's what this would be. How many wipes per week? Right? If you double that,
Yeah, so it lasts
240. Oh. So what's 1,200 divided by 240?
5.
5. So it lasts 5 weeks. If we're doubling it up, it's only gonna last 5 weeks. There's 9 weeks of school left. I don't know. Maybe they'll give me a new bucket.
No, it's not gonna last very long.
I figure we just do 1 wipe, though, just beginning of class. At least it's gonna last me until the end of the year. But I'd rather do that.
It makes more sense logically.
Yeah, I like it. All right, guys on Zoom. Well, we're gonna start wrapping up here. So if you guys want to start packing up your stuff, bell will ring here in a few minutes, and you can grab up. Oh yeah, we won't do wipes at the end of class. We'll just do it at the beginning when you come in. You know, and I'll just have my next class as they come in. I'll have them wipe down their desk, wherever they sit. So let's see here. So you'll go on to your 3rd period class and then 5th period after that. You'll have a grab and go lunch at the end of the day. And then tomorrow you'll go to 2, 4, 6. Same thing, but periods 2, 4, and 6. What else? Wednesday we'll do makeups and test corrections. So that test that we took last week, if you missed it, we'll do makeups on Wednesday. If you took it already, you can do some corrections and get back half those points you lost. So good opportunity to pick up your grade and stuff like that. So and that's it. So all right, so people on Zoom, we'll see you later. See you next time. And close out our meeting here. So bye now.
See you, teacher.
Bye, Bryant.